Hello, welcome. This is going to be a review lesson for everything that we've covered up in the algebra unit so far. So first I'm going to briefly go over the quiz that we did on the last day one more time, just to cover, because that covers mostly all the different kinds of questions that you'll be seeing. And then we're going to eventually continue to do our lessons, um, complete our 2 lessons that we didn't get time to do, after which you'll have your assessment online. So, fun times. Hopefully, everybody's, safe and okay and virus free, and having fun as much as we can at home. So we'll dive right into it. The first question is an addition question where we simply have to collect like terms. So we'll see here that we have like terms. So again, like terms are terms that have the same variable part to it. So we have a 5x squared, a negative half x squared, minus 2x squared. So we're going to put those like terms together because we have to collect and add like terms. So we'll see here that the brackets have positive signs around them. So we don't necessarily have to change any of the signs. We can just remove the brackets. I'm going to skip that step. I'm not going to do anything about the brackets. Because they have positive signs around them, I can just pretend they're not there for all intents and purposes. So I have a 5x squared minus half x squared minus 2x squared. So again, we're going to do this little calculation. 5 minus 2 is 3. 3 minus half is, well, hopefully we can see 3 minus half is 2.5, which is 5 over 2. If that's, we're going to do a little calculation here. You don't have to show this level of calculation, but that's 2.5x squared. Next, we're going to collect our x terms, 1 over 3x, 1 over 2x, 1 over 5x. Don't forget the minus sign that goes in front of the term. It follows that term, so that's negative 1 over 3x plus 1 over 2x plus 1 over 5x. So again, we're going to need a common denominator here. Common denominator between 3, 5, and 2, I believe, is 30, I think. Yeah, so times 6 times 6 times 15 times 15 times 10 times 10. So what we have here is minus 10 plus 15 plus 6 over 30x, which gives us 21 minus 10 is 11 over 30x. Sorry, that's just my cat playing in the background. Hopefully. The constant terms, or the terms without a variable, is 5 over 2, negative 1 over 3, negative 1 over 6. Again, common denominator, 2, 3, 6 would just be a 6. So here we have 15 minus 2 minus 1 over 6, which is 12 over 6, which is 2. And then we're going to put these terms together. So we have our final answer is 5 over 2 x squared plus 11 over 30x plus 2. So this is addition of variables where you're just collecting different like-termed pieces. The next question is a bit more complicated. The first one was a bit of a warm-up, I guess. The next question involves 2 operations. The first is what we call distribution of a monomial. So that's the easy kind. We see here that we have a term outside a bracket. So whenever you see, so we looked up here, the only thing that was outside the bracket was a positive sign. So that just means there was a plus 1 outside the bracket. And we know that 1 multiplied by anything is the same thing. So opening this bracket just involved removing the bracket, because I did plus 1 times this, plus 1 times this, plus 1 times this, which just gave me the same thing. So I didn't have to really worry about it. And this is why if you had a negative sign outside the bracket, you consider that as a negative 1 outside the bracket. And you go negative 1 times the first term, negative 1 times the second term, negative 1 times the third term. And all the signs basically change because you're multiplying everything in the bracket by negative 1. So now here we have something that's outside of the bracket. So we have a 2x squared outside the bracket. So we'll remember we have to multiply the 2x squared into everything inside the bracket. So 2x squared times x cubed. Now we'll remember that addition and multiplication are a bit different. What did I do when I added these three terms? I just added the coefficients and kept the same variable. The variable was still x squared. That did not change. Right? So adding variables is much like adding fractions where we, add the numerator and keep the same denominator. Here we add the coefficients and keep the same variable. It's like 5 apples minus half an apple minus 2 apples gives me 2.5 apples. The variable part stays the same. You just add the coefficients. However, that is different when we do multiplication. When we do multiplication, we multiply the numbers and we multiply the variables as well. So here we have 2 times 1, which is 2, and x squared times x cubed, which we'll know from our extensive practice on exponents, is x to the power of 5, or 2 plus 3 gives us 5, right? But I also have to do 2x squared times this term, the x term, because that, again, is using the distributive property. Anything that's outside the bracket gets multiplied into everything inside the bracket. So here I have minus 2, because I had a 2 times minus 1, and then x squared times x is x to the power of 3. Let's look here. Again, I have something outside a bracket, and then times the bracket term, and then I have, so therefore I have the distributive property where I take this minus 3x and I multiply it into everything inside the bracket. So 1x to the power of 4 and 2x. So this would give me negative 3x to the power of 5 minus 6x squared. Again, I'm just using exponent laws to add the variable part, to multiply the variable parts. And the same thing I'm going to do here, distributive property with negative 2x to the power of 4 plus 6x squared. And here I'm going to now collect like terms. I have 2x to the power of 5 minus 3x to the power of 5. That gives me minus x to the power of 5. Again, you can write this out. I'm going to skip a couple steps here because we're getting better at this hopefully, but 2x to the power of 5 minus 3x to the power of 5 gave me negative x to the power of 5. Well, hopefully we're collecting some of the stuff. And now I have only one x to the power of 4 terms, so that's just going to stay here. Minus 2x to the power of 4, nothing to add to that. Minus 2x to the power of 3, there's nothing else with that term either. And then I have a minus 6x squared plus 6x squared, which gives me a 0. So minus 6 plus 6 is 0x squared, which gives me 0, which is, again, 0 times x squared is 0. The rule of multiplication doesn't change there. Anything multiplied by 0 gives me a 0. So what I have is just these three terms, which I can just write in one line. Was this a cubed? Yeah, this was a cubed. There. That should be my final answer. Right, so we'll hopefully we're recollecting some of this stuff. I know you have all the answers at home. I'm just going over this in the hopes that we're trying to recall some of this stuff. I know it's been a long break, so okay, where were we? Next question. Next page. There we go, finally. find the area of the rectangle shown below. So again, this is a fairly straightforward question if you know what laws to apply or what rule to apply. Here we have two expressions given for the length of the rectangle and the width of the rectangle, and we know that the area of the rectangle is just length times width. It is important here to put brackets. One of the mistakes that I found and that you said that you did on the test was to forget to put brackets around these terms, which is very important. Whenever we have expressions, we want to start off by putting brackets around them and then think whether, okay, do I really need these brackets or do I not need these brackets? Here I do need these brackets because I'm doing all of this multiplied by all of this. So if you did put the brackets and your expression just looked like that, say, and you just had a multiplication here, you would maybe you would do something like 5 times x and 5 times 2, or just do this part and leave it at that. But we know that we're not necessarily doing that. We're doing the entire length multiplied by the entire width. So just be careful there. So again, here we're going to use the distributive property, and we are going to use we're going to use the thing that we use. We're going to do the first term multiplied by everything here, second term multiplied by everything, and then the third term multiplied by everything. We're calling this the crab claw or the clamshell, whatever we wanted to call it. But again, it's basically you take this first term in the bracket and then you multiply it with everything in the second bracket. You take the second term, multiply by everything in the second bracket. You take the third term, multiply by everything in the second bracket. It's just distributive property applied to multiple terms. So first we have 2x squared times 5x plus 2. That's our first bit. Again, here I'm going to use what we are calling Arya's method, where I split this up into different parts so that it's easier to write. Again, you can do this many different ways as long as you get the same answer, and you should get similar sub answers as well. You're fine. So 2x squared times 5x, 10x to the power of 3 plus 4x squared. Hopefully everybody sees the distributive property here. Minus 15x squared minus 6x. And here we have 25x plus 10. Again, distributive property applied to each of these small brackets. And then I'm going to combine like terms. I could have written this better where my like terms kind of lined up. So I'm going to do that. I had a minus 15x squared minus 6x. And here I had a 25x plus 10. So what I've done is I've just written it so that all my like terms are underneath each other so that it's easier to add them. I have 10x to the power of 3 minus 11x to the power of 2. Whoops. What is 25 minus 6? Positive 19x plus 10 units squared. And this here is my simplified expression for area of this rectangle, and that's how you kind of do this question. That basically, this is how you do multiplication over brackets. So hopefully that was good. Find the shaded area shown below. Okay, we have a complex figure, as in we have a kind of combination of two different figures. So what I'm going to do is I'm going to split the rectangle right here and call this rectangle part 1, and then the other part here will be rectangle part 2. So part 1 rectangle, we know that we have to do x plus 4 times x minus 4. So that's what we're going to do with our first rectangle. We have to do, again, length times width in our first rectangle This is the length, this is the width. And then from our second rectangle, we have 4 times 8. That is my length, that is my width, and that is my area of the second rectangle. So here again I had my distributive property, crab claw rule, right? X times X. X times X, X squared, minus 4X. Here I have a plus 4X, minus 16. That's all only for my first rectangle. I still carry forward this plus 32, which is 4 times 8 for my second rectangle. Here I'm going to add everything together. I've written this out nicely so that after I've done the distributive property using my crab claw rule, I have all my like terms right under each other. So I have an x squared minus 4x plus 4. So minus 4 plus 4 is 0x, and 0x is 0. So I'm not going to bother writing a plus 0 because it's kind of useless to write. So I'm left with, I can just cross those out because those give me a 0. I'm left with minus 16 plus 32, which just gives me x squared plus 16. And this is my final answer for the shaded area, which is basically the area of that entire thing. I'm not going to solve the bonus question. Instead, this is again just the distributive property. I know a lot of you have the answers and we've already covered the distributive property. So for the second half of this review, I'm just going to go over some of the questions that we had over here, and we're going to see how to solve these questions. Again, I'm not going to do all of them. I'm just going to give you an idea, maybe one of each kind, and how to do these kinds of questions. So here we have a find the perimeter question. We obviously have 2 sides missing here, but we can obviously, since this is a rectangle, kind of assume that, well, not assume, but know that the length and the width are applicable to both sides of that rectangle. So to find the perimeter, we're going to have to add 4x minus 7, that's this one, plus 2x minus 3, plus another 4x minus 7, plus another 2x minus 3. So I'm just using the simplest formula for perimeter, which is add up all the sides. Here we are looking at the like terms, and we can see that 4x plus 2x plus 4x plus 2x gives me 12x, where I just added all the coefficients, and I have minus 7 minus 3 minus 7 minus 3 gives me negative 20. Those are my constant terms. If you were maybe a bit more fancy schmancy, you would do 2 times 4x minus 7 plus 2 times 2x minus 3, and simplify it this way. You would get 8x minus 14 using distributive property, plus 4x minus 6, which would again give me 12x minus 20 after I collected like terms. So again, same idea. Why did this disappear? Same idea, different ways of doing it. Both are equally correct. Let's take a look at this one. I like this question. It's a nice question. Expect to see some of this in your assessment. However, that assessment may be administered, probably an online, probably just a quiz. We're going to see here that we have a perimeter, and we have 3 different sides, and we're asked to find this mystery side over here. So without getting too complicated, let's just think about how we were to do this, right? So we have the total. So if we add, we know if we add up all these sides. So if we do 5x plus 7x plus 2 plus 4x minus 5 plus this mystery side. So again, if I have a mystery side, I can just label it as y. So I don't know what y is. I have to find y. And this all equals 21x plus 2. right? So we can write out some form of equation like this. We can add up all this, and then we can move things to the other side. Again, this is a slightly more complicated form. If hopefully we are all seeing that to find the missing side, all we have to do is add up these three sides and subtract that from the perimeter. That will give us the length of our missing side. So if we see that, we can just write missing side. We don't need to add any extra variables like y. We can just say missing side equals perimeter, which is 21x plus 2 minus bracket the sum of all the other sides. What was this side? 7x plus 2. 7x plus 2 plus 4x minus 5. Right? So this was our perimeter minus the sum of all the other sides. Important to put in brackets because we do have to add these three things first, figure out how long this is, and then subtract that from the total perimeter so that we get our missing side y. So here we have 21x plus 2. I'm going to leave that as it is. And first, again, I could expand this. So we know that when we have a negative sign outside a bracket, when we have a negative sign outside a bracket, we know that we have to multiply everything inside the bracket by -1. So you could do that immediately. -5x, -7x, -2, -4x, +5. But we're not going to do that because we can simplify inside the bracket first. We see here that we have 5x plus 7x plus 4x. I'm going to nicely combine those things to make 16x. And then I have plus 2 minus 5, which gives me -3. Why am I doing this beforehand? Because now I have only two terms to apply the -2. So this is 21x plus 2 minus 16x plus 3. I have moved the -1 inside the bracket. Very important to change all the terms in the bracket. So we have done that successfully. 21x minus 16x is 5x, plus 2 plus 3 is plus 5. So this is our missing side length. So that was a kind of trickier kind of question. So hopefully everybody is good with that. Again, to do this, the same kind of idea, we would do 3x squared minus 2x minus 5. That's the total perimeter. And we're going to subtract the sum of the other sides, basically, how many ever sides there are. Plus 3x, whoops, I'm running out of space, plus 4. So again, I would first combine all the terms inside my bracket, simplify my bracket first, move the negative inside, and then just do the subtraction. Or after I move the negative inside, it basically becomes just combining like terms, adding like terms, or subtracting, whichever operation you're doing there. So that was that. I'm going to do one other question. Hopefully we'll see that questions like these are fairly straightforward. We have to find the shaded. I'm going to skip this because the part 3, because part 4 is just an advanced level part 3. So find the area of the, well, not really. We have a different kind of multiplication here, but we've seen this kind of multiplication. So nothing to worry about. Here we have a little mini square, mini rectangle, and a big rectangle on the outside. And so here we can say that, hopefully we see the straightforward way to do this is to find the area of the big rectangle and subtract the area of the small rectangle, which will give us the area that's in between there. So we're gonna go ahead and do that. 6x squared times 11x plus 20. Again, very important that this is multiplication, so we kind of already have to know we're using the distributive property, but it's important to put the brackets around that just to emphasize, or just to show that we are actually doing the distributive property. We're going to subtract 8 times 10x squared minus 3x. Before I go any further, I know some of you were asking, if we go back to our surprise quiz, that this question could technically be done the other way. It doesn't matter which order you multiply these things. If you want to put 5x plus 2 first, and then do this multiplication, that works as well. You will get the same answer if you did 5x and then 2x squared minus 3x plus 5. And here if we did plus 2, 2x squared minus 3x plus 5. The same, and if you, did all of these and added them together, you would get the same answer. All right, so just going back to this distributive property, 66x to the power of 3 plus 120x squared minus 80x squared plus 24x. So this is our distributive property used here. Then I'm just going to collect like terms. Gives me 66x to the power of 3 plus 40x squared plus 24x. This is my final answer for the shaded area. So we'll see that was this answer over here. So this would be a W. And you hopefully have filled in the rest of these questions and done the practice. Again, this would be, I don't expect all of you to actually watch this video. Those of you who got that far, I commend you on being an excellent watcher of YouTube videos. But I realistically, hopefully this was just a refresher. If you have forgotten some of the stuff, I would recommend going over these practice, or if you haven't done them already, doing these worksheets. Again, we're just going to do one distributive property question before we finish. Actually, we're not going to do it because these distributive property questions we've already done. For reference, check the surprise quiz, and we've shown how to do these kinds of questions. So this was an extra long video. The other videos won't be this long, but this is just to make sure that everybody's on the same page as far as moving forward with new material is concerned. All right, I will see everybody I will be talking to everybody in the next video. Until then, peace out.